Good afternoon, Year 5. Welcome to our geography lesson this afternoon, where we're going to be learning all about the Ring of Fire. So I would like to start today's lesson by showing you a video.
Welcome, boys and girls. Today, we're going to learn about the Ring of Fire. It's a story of volcanoes, earthquakes, and a burning ring of fire. Okay, so it won't really be a ring, and it's not technically on fire, but it's still pretty interesting, trust me. To start with, let me ask you a question. What if we plotted every known volcanic eruption on a map of the world? Let's see what that looks like. But before we start, I'm going to move our map, like so. And you'll see soon why we do that. So we begin with the oldest eruption on record at the Smithsonian, from roughly 13,000 years ago in what is now Chile. And as we move through time, you can see volcanic eruptions all over the world, in New Zealand, Asia, Africa, in the middle of the Pacific and Atlantic Oceans, and even some eruptions in Antarctica. If we were to trace where a majority of these volcanic eruptions have occurred, a pattern quickly emerges. And this, my friends, is the Ring of Fire. Now, as I said earlier, it's not quite a ring. It looks more like a misshapen horseshoe. And it's not quite on fire, although a lot of hot lava has flown through this area. But doesn't Ring of Fire just sound much cooler than misshapen horseshoe of volcanic lava flow? So Ring of Fire it is. But just how many volcanoes have erupted in the Ring of Fire? To find out, let's go to our friend Sally the Sloth, who lives in the forests of South America. I bet she's seen an eruption or two. Sally? Sally? Sally!
What? Why did you wake me? I'm so sleepy.
Sally, look around you.
What? Ugh. Did I sleep through another eruption? Not again.
Sally, while you're awake, will you please tell us about volcanoes and earthquakes in the Ring of Fire?
Oh, sure. Why not? It's not like I can go anywhere for a while. I've lived in the Ring of Fire for a few years now, so I know a bit about volcanoes and earthquakes. But scientists have records dating back to almost 13,000 years ago. They have recorded almost 10,000 eruptions all over the world, and nearly 8 out of 10 have been right here in the Ring of Fire. And if we're talking about the really big eruptions, it's even more. Nearly 9 out of 10 of those have happened here. Did you know that earthquakes and volcanoes are very closely related? It's true. More than 2/3 of big earthquakes, and I mean earthquakes that can damage buildings, have happened right here in the Ring of Fire. In fact, in the last 50 years, we have had 23 earthquakes measuring over 8, and all 23 have been here. It's been a little shaky. Let me tell you, the Ring of Fire is no joke when it comes to earthquakes and volcanoes. Now, how do I get out of here?
Don't worry, Sally. I'll send out a chopper. See you soon. To find out what causes earthquakes and volcanoes, we have to look inside the Earth. Now, if you pop the Earth open, you see the different layers inside. The outermost layer, which we live on, is called the crust. Below the crust is the mantle, and below that are the outer core and the inner core. Now, let's take a closer look. If we were to take the world's longest thermometer, which I just invented right now, and start sticking it deep inside the Earth so we can see how hot it gets, what we would find is that the outermost layer, the crust, has an average temperature on the outside of a nice comfy 60 degrees. But as you start getting to the bottom where the crust meets the mantle, the temperature rises to about 400 degrees. And just as a point of reference, water boils at 212 degrees, so we're already getting pretty warm here. The mantle is where it really starts to heat up. From 400 degrees at the top part all the way to 7,000 degrees at the bottom, where the mantle meets the outer core. And to give you an idea of how hot that is, a Neapolitan pizza, which is a pizza from Italy, cooks at about 900 degrees, and iron melts at 2,800 degrees. Going further down, the outer core gets as hot as 9,000 degrees, and the inner core gets even hotter, going up to 13,000 degrees. Now, what'll really blow your mind is that the temperature at the surface of the sun is a little under 10,000 degrees, so the inner core of the Earth is actually hotter than the surface of the sun. Okay, so what does all of this have to do with volcanoes? The answer lies in something called tectonic plates. Tectonic plates is how the surface of the Earth is divided, and they go as deep as the top portion of the mantle. You can think of the tectonic plates as floating puzzle pieces, like so, that are held together as part of the Earth's surface, but sometimes rub up against each other with some very interesting results. And the way in which tectonic plates rub against each other really matters. One of these ways is called subduction. When an ocean plate collides with a continental plate, the ocean plate subducts or gets pushed under the continental plate. And as the plate subducts, it heats up, it releases water, which then creates magma pools, and this magma rises to the Earth's surface to create volcanoes. Here you see a divergent boundary, where two tectonic plates are moving away from each other. Now this creates a gap in the Earth's crust, and magma quickly rises up to fill the gap, and you guessed it, creates a volcano. There are also areas within tectonic plates that are called hotspots, which are places where plumes of magma just well up from the mantle and create volcanoes. Now these don't require plate interaction at all, they can just occur anywhere within a plate. So like it or not, you can't escape a volcano. And finally, when two tectonic plates slide against each other, they create a transform boundary, which leads to earthquakes. And like volcanoes, earthquakes can also occur within plates where there are faults or weak points. Now let's get back to the map. And we'll move our map to the east again, and we'll start drawing the tectonic plates. Now as we draw these plates, you start to see how some plates are next to other plates, which are next to other plates still. And at the center of it all is this large Pacific plate, which rubs up against many other plates, and where all of these plates collide with the Pacific plate and with each other, we see, you guessed it, the Ring of Fire.
Okay, so I'm just going to summarize the main points of that video. So what is the Ring of Fire then? The Ring of Fire is a horseshoe-shaped line on a map which is home to around 75% of the world's volcanoes and 90% of the world's earthquakes. The area is 25,000-mile line of volcanoes, tremors, and earthquakes around the edge of the Pacific Ocean. So why do earthquakes happen? As we know, because we've been learning about mountains, the Earth's crust is made up of lots of pieces, and we call those pieces tectonic plates. So when the edges of those tectonic plates rub against each other, they cause sudden movements, and that can lead to earth tremors or earthquakes. So here's a map showing you the earthquake hotspots around the world, and you should notice when you look at them that the hotspots are all around the edge of the tectonic plates where they meet. So what makes the Ring of Fire so special then? So one way that a tectonic plate meets and moves is when one slides under the other, creating what is known as a subjunction zone. The boundary of the Ring of Fire is mostly subjunction zones, which are more likely to cause earthquakes. The subjunction also leaves behind trenches, and we know trenches are the very deepest parts of the ocean. For example, the Mariana Trench. This is the deepest known trench in the Earth's oceans, and it was formed when one tectonic plate moved beneath its neighbour. It's 7 miles deep and is found just to the east of the island of Guam. Challenger Deep is the deepest part and also the deepest known part of our oceans. And it's 10,898 meters, which is bigger than the height of Mount Everest. There are at least 452 volcanoes in the Ring of Fire. Here are some of the more famous or important hotspots. You might have heard of some of these before. So we've got the Cascade Volcanic Arc, and that's a range of mountains containing 13 major volcanoes, one of which is Mount St. Helens, and that erupted in 1980. We've got the Aleutian Islands in Alaska, and they were formed from volcanoes of which there are no less than 52. So these hotspots, we're not talking about there just being one volcano there. We're talking about huge groups. Mount Ruapehu is the largest mountain and active volcano in New Zealand. Mount Tambora is the largest recorded volcano eruption, but that was in 1815. Krakatoa is a volcano that makes a whole island in between Java and Sumatra. It erupted in 1883 and also led to the emergence of a new island in 1927. Mount Fuji, which is in Japan, is the tallest mountain, but also a volcano that last erupted in 1707. So, I'm going to let you continue to read those as you wish. The activity that I would like you to do is, hopefully you can see on my screen now, there is a map of the world with the tectonic plates outlined. You have got to label the names of those tectonic plates, please. Then, when you've done that, you can do these things to do next. So find out more about what the Richter scale is. Find out more about the discovery of Challenger Deep, so the deepest part of the ocean. Find out more about how earthquakes are predicted, and find out the difference between a tremor and an earthquake. And that should also link to the Richter scale. Don't forget to send your work to me, Mr. White, or Mrs. Newbold. Thank you very much. Hope you enjoyed the lesson.